Welcome to Antenna by Panda once again. Today I will be showing you how to tune a two-stack Yagi antenna or twin Yagi antenna. Our primary requirement would be to obtain two antennas with similar characteristics in terms of impedance and frequency response, including antenna pattern. So that can be easily obtained from your antenna manufacturer. When homebrewing, make sure that the frequency response and measurement of your antennas are similar. Slight misalignment on the frequency response is acceptable, but as much as possible, we would like it to be close as possible. So, what we will be doing next is to test this antenna individually using a piece of RG58 coaxial cable. We also have a 2-meter coaxial cable. This is low loss. We also have a piece of Belden coaxial cable, about 10 meters. This one is Belden 8237, about 7 meters. So we would test all those coaxial cable with this antenna once we connect the pacing harness. So first we need to test the frequency response of the antenna individually. So I will be checking the frequency response of the antenna on the right using my vector impedance analyzer. So let's do that. I will connect the short piece of RG58 coaxial cable for testing. I have now connected the coaxial cable or patch cable to my vector impedance analyzer. As we can see, it's very short. So let's check the frequency response. As we can see on the display of the vector impedance analyzer, we have 1.078 on single frequency response, or about 1.1 SWR at 50 ohms. Impedance is 50 ohms as well, with S11 of 28.32 dB. So let's check the frequency sweep. By changing the display. So as we can see here, we have S11 at 145 is 28. So let's check the VSWR curve on see the frequency sweep. So we have to adjust. So that's our VSWR curve. As we can see, we have 142, 150. Our SWR on 145 is 1.078 or 1.1 if we round that up. So let's check the impedance is 50 ohms. Resistive load is also 50 ohms. We have reactance is minus 3.771. S11 is 28.28. So that's our frequency response of this antenna on the right side at 1.079 VSWR. The impedance is 51 ohms or 50 ohms. Capacitance is 297 picofarad. So let's check the left side antenna and see the frequency response. I have now connected the patch cable on my vector impedance analyzer, and let's see the frequency response. This is the left side antenna. So on the individual frequency response of this antenna, as we can see, we have 145 is 1.074 at 52 or 53 ohms impedance. It's 500 picofarad at 28.82 dB. So let's check the frequency sweep. As we can see, we have almost similar frequency response. This is the S11 curve. Let's move the settings to, this is the VSWR curve, 140 to 150. We have 1.072 or still 1.1 if we round that up at 145. Impedance is 53 ohms. Slight mismatch because we are not in a perfect world, so that's acceptable. Resistive load is 53. Reactance is about minus 2.147. So now we will be connecting the antenna with our pacing harness. I have now connected the pacing harness to the antenna system, both the left and the right, connected to a T connector going to the vector impedance analyzer. This is still short cable run. So let's check the frequency response. As we can see here, we have at 145 when the pacing harness is connected, the SWR now is 1.132. Impedance is 52 ohms. S11 is 24. It's now inductive. So our center frequency actually shifted a little bit. So we can see that on the frequency sweep. So let's check the frequency sweep analysis. So our center frequency now becomes 144.6, still very much acceptable at 30.85 dB S11. The frequency sweep is still 140 to 150. So let's check the VSWR curve. So as we can see, the VSWR, we have lowest point is 1.058. At 144.6 or 1.1 still. Even if we move that to the center frequency, which is 145. So let's move it to 145. So we have 1.1. Let's check the impedance. So impedance is still 52 ohms. Resistive load is 52 ohms. Reactance is now 6.108. So as we can see, it has little effect even if we connected the pacing harness. Now let's connect it to the feed line. First, the low loss coaxial cable. But first, let's check the frequency response of this from 140 to 148. So let's move to single frequency display. So let's check. Going to 148 is 2.6, going down to 140 is 1.9. Center is 1.1. Very much acceptable response on the amateur frequency band. So let's check it with the short feed line, the low loss coaxial cable. I have now connected the antenna with the short run of coaxial cable, the low loss coaxial feed line, about 2 meters, going to the vector impedance analyzer. As we can see, on the center frequency is still 1.1 at 45 or 46 ohms impedance. Now it's capacitive. The antenna system is now become capacitive. So let's check the frequency response. This is the S11 carb at 25.64. So let's check if our center frequency actually moves a bit, going up. So let's check that. So that's our center frequency now. It's 145.4 at 29 dB, minus 29 dB, S11 carb. So let's check the VSWR carb on the frequency sweep analysis. Let's move the cursor to VSWR. So as we can see, VSWR 1.074 at 145/400, still 1.1, still the same frequency sweep, 140 to 150. Center frequency is still close to 1.1, so let's move it to 145. So still 1.1 on 145. This is using the low loss coaxial cable, which is about 2 meters in length. So let's check the individual frequency response from 140 to 148. So it's 145 is 1.1 going down to 140 is 1.9, 141 is 1.8, 140 is 1.7, 143 is 1.5, 144 is 1.3, 145 is 1.1, 146 is 1.2, 147 is 1.5, 148 is 2.1. So now let's check the frequency response using the Belden A237, about 7 meters, still 50 ohms. I have now connected the antenna with the Belden A237 coaxial cable. This is about 7 meters, so it's now connected to the vector impedance analyzer on my hand. So let's check the frequency response. As we can see here, we have 1.158 on 145. The antenna system has become capacitive at 166 picofarad. Impedance is now at 54 ohms. Resistive load is 53, and reactance is -6, and S11 is -22. So let's check the frequency sweep. As we can see here, we have the VSWR curve. The center frequency has now shifted downwards again, but 145 is still on 1.1. So let's check the exact center frequency now when we change the length of the coaxial cable. So it's now 144.7 at 1.066, or that is much lower. 144.6 at 1.050. That's the bottom of the curve. Still the sweep is 140 to 150. So let's check the S11. S11 is now 32, -32 dB, or the antenna reflection coefficient. We have reactance is -2.417 ohms at 144.6. Resistive load is still 49.63. Impedance is 49.68. That is on the exact center frequency. Resistive load is 49.63, impedance 49.69. VSWR 1.050. So let's move it to 145. So still 1.1 at 145. Let's check the variables again. Impedance is 54. Reactance is resistive load is 53. Reactance is minus 6 ohms. 6 ohms. S11 is 22 on 145. VSWR is 1.1. Let's check the frequency response. Individual frequency response from 140 to 148. So 140 is 2 is to 1. 141 is 1.9. 142 is 1.7, 140 is 1.4, 144 is 1.1, 145 is 1.1, 146 is 1.5, 147 is 1.9, and 148 is 2.4. So let's check the another feed line, which is the Belden 9913, which is about 10 meters. I will now connect it to the antenna system.